Hello everyone. In this video I will explain three notions which are important for mandelbrot sets, which are also important for the explanations of my graphical user interfaces. The notions are escape count field, and maximum number of iterations. If you know what these words mean, you could skip this video and go directly to the other videos of this playlist. Well, for the others, I prepared one PowerPoint slide where I explain how the image of a mandelbrot set is created. So be aware the members of the mandelbrot set are complex numbers. Therefore, we have to cover the central part of the plane of complex numbers with a 2D array. I choose the shape 1000 by 1000, and here you can see the limits. So this is the 2D array. It has 1 million pixels, 1000 by 1000. And to show you the limits, here you can see the coordinates of the mouse. So the real part goes from minus 2.25 to plus 0.75, and the imaginary part goes from minus 1.5 to plus 1.5. Now we have to choose a complex number from the 2D array and test whether this complex number C is a member of the mandelbrot set. We do this by iterating this formula. I have it here already written. We start at Z0 equals 0, and n will run from 0 to infinity. Because we cannot count until infinity, in practice we have to introduce an iteration limit, which we call max iter. To be very explicit, for n equals 0, we have Z0 equals 0. And for n equals 1, we calculate 0 squared plus c is c. And for Z2, we have Z1 squared plus c, and so on. I show you how this sequence of complex numbers develop because I added a small feature to display this. So with a mouse, I select numbers C from this image, and the polygon shows you how the sequence of the n's evolve. And outside the mandelbrot set, it goes to big numbers, and inside it stays within bounds. And if you come close to the border, you have these nice structures which appear. Okay. So this is a sequence of complex numbers which are generated by the iteration. Now, after every iteration, we have to test whether the length of the complex number stays within bounds or tends towards infinity. What is the length of a complex number? So we have here somewhere the origin. You can see it here. So 0, 0. And we choose a number C, maybe here. And then the distance between C and the origin is the length of a complex number. Okay, so testing towards infinity, whether it runs towards infinity, we don't have to do this. We know that if for one Zn the length is greater than 2, we know that the sequence goes to infinity. Then we know that C is not a member of the mandelbrot set. And we store the escape count, the number n, where the border was crossed, in a 2D array, and we call this array the escape count field. The escape count will be used to select the color, and therefore the colors tell us how fast the sequence of iterations escapes. Let's take a look. So I move the mouse here, and here you can see the escape count. So for this C, the escape count is 3, here it's 4, 5, and so on. Now, if the length of the n is less than 2, we continue iterating until we reach our iteration limit, and there we assume that C is a member of the mandelbrot set, and we store max iter in the escape count field. So the maximum number of iterations is 1024. And here you can see we are here in the mandelbrot set, and there you see it's 1024. So be aware, we never know whether a complex number C belongs to the mandelbrot set, because we cannot make an infinite number of tests. So, and this means that if you increase the number of tests, the better we know. And just for demonstration, we can reduce the number of tests here. When we go to 16, you see very bad resolution, and if we increase the number of tests, the mandelbrot set becomes better defined. Okay. Now to conclude. Now you should know what escape count field, and maximum number of iterations mean. And now you could go to the other videos of this playlist. And I thank you for watching.